spatial memory, the component error assumption. And well, let me just click on this. And so I want to talk about spatial memory. All right. And the first thing I want to do is give you some idea of what kind of things I'm talking about. All right. We've been doing spatial memory for quite a long time. All right. And I initially got into it because I was interested in the question of what about environments makes them easy to learn or more difficult to learn. So we were manipulating environments. So all of our research uses virtual environments so we can manipulate them easily. All right, for that. And so that was a big part of what we were doing. All right, and but we found an awful lot. But more recently, I moved into another question, and that was how do we measure it? All right, and so I'm now a co-host of the meeting. I don't want to be a co-host. All right. Anyway, was basically, I'm going to go try to share again. What?
Are you able to share your screen? Because we're not seeing it. I'm not sure if you've already tried to share it.
I'm trying to share it.
Okay.
Share content, connecting. Anyway, and one of the difficulties is, all right, for the kinds of stuff we're doing, all right, there's only one measure that's mainly been used, and we weren't particularly enamored with it, all right, from that. How about I email you this thing, all right, and you put it up? Can you do that? What?
Yes.
All right, anyway. Oh no. Oh, oh wait, yeah, I still got it there. I just didn't know I had it. Okay, so Pam Garver, brown bag today, forward, or reply, sorry, attached files. Desktop, brown bag. It should get to you soon. Okay. All right. So, and as soon as you put it up, I can see my slides. All right. I hope I'm going to get rid of this share content. It's still connecting for some reason. So try to get out of your way. Sorry. All right. I hope I tried to get on 15 minutes ahead of time, but I was struggling the whole time, and it looked like you wanted me to be host, and I didn't want to be host. I didn't know how to be host. So anyway, all right. So measurement in psychology is often done, all right, in the functionalist tradition. We find, all right, a measure that looks like it tracks a phenomena we're interested in. We quantify it. We start measuring it that way. All right. And if we do validity, well, sometimes what we do is we, get another measure, which is the same thing, and we correlate them. All right. And that's there. That's different than what's done in other sciences. Other sciences, all right, they try to, did you get my email? Why not?
No, I still don't have it.
What?
I do not have it.
It can sometimes take some time to send larger files.
I sent it. So
I believe you.
what?
I believe
I'm
you. I just
checking my
have
sent file. I'm sorry. It's sent. All right. So anyway, um, I and so they actually have measurement models that go on, and they look at it in a context, and they often can measure things because they know relationships. So they measure force through physical work and mass. They can measure it with a pan balance, but they can also measure it on hanging things on a spring, like we have on our bathroom scales. All right, because of Hooke's law, because they know Hooke's law. All right, and as you'll see, that's something that we did in our past research. All right, we started looking at, all right, the relationship between, all right, still income. Okay, we started looking at the relationship between our measure of things. Well, there's several different measures. All right, we use angular measures. All right, I'm being hampered. Oh, I should bring my slides up here and I can look at them. All right, so, all right, and so there's different types of spatial memory. So first of all, you need to know that what I'm studying is navigational spatial memory. I mean, there's spatial memory where if you throw a pen on a table, you can close your eyes and you still pick it up. All right, reach for it. There's root memory, all right, which means that you know how to get from your, from your house to the department store, all right, and you know the streets and turns and so on. That's largely language with with spatial turns information and so on. All right, I'm not interested in that. That's the GPS type stuff. What we're interested in, the layout memory. This is knowing angles and distances, all right, from naturally going through an environment without, all right, actually having other information like a map or directions or even cardinal locations like north, south, east, west. All right. And then finding out what people know about that environment. All right. And to do that, all right, people measure angles or distances, and we measure angles because they're a lot easier to measure. And I don't have time to go through why. Angles are much easier to measure than distances, but we do. All right. And how do you measure angles? One way is through direction circles, a big circle you put up and they mark it. All right, or they do it on paper, they do it on a computer screen. I'll show you in a little while one of our computer screens if we can get this up. Arrow pointers, or just use their hand to point. We also use maps, all right, and we measure angles on maps, all right, from that. So is that up now?
You have to, you're muted, Pam.
I'm muted? No,
No,
I've
Pam.
got my microphone's on.
Herb, your slides are up.
Okay,
Pam was
good.
muted.
Oh, sorry.
Okay.
You
Can we make
Pam.
them, maximize them? Okay, so go, you're gonna have to change slides since you're under control, Pam. I'll tell you what the slides. This is old school when we used to have, all right, slide projectors. All right, we used to have to tell the projectionist, all right, what to change slides. All right, customize your view by dragging one or more videos to stage. All right, I don't want to do that. It says got it. All right, anyway, change slides.
So what slide do you want her to go to?
Just slip through them. I'll tell you when to stop. The next one. These are one of the things I've talked about. All right, the next one. Oh, wait, you're way too far. Go back up. Wait a minute. What's going on? I don't have slide numbers and I couldn't find how to put it in there. All right. So wait a minute. I can't go. I want about slide 3 or 4. Oh, I got the wrong, I sent you the wrong one? Oh, God.
Ah, now I can unmute myself. But when I was in full screen, all of my video controls were gone.
Okay, I sent you the wrong one. Damn it. I couldn't, I wasn't seeing because I was just loading there.
Yeah, this
I
one
thought
is
I had-
from April.
I had two brown bag folders and I grabbed the wrong one. It was an older folder from an earlier talk. All right. And that's why it didn't make any sense to me. Here is the correct brown bag folder. And I've verified it now by looking at the file name more closely. So I just sent it to you. Anyway, all right. One of the things that we found was that, all right, we have two measures. And we measure directional things on a direction circle, all right? And I was showing you which ones we use, just a computer screen showing the direction circle, all right? And we also collect sketch maps, and people draw sketch maps, which are line drawings, and they draw the rooms in, they leave spaces for the doorways, they put objects in, all right, inside the rooms, and they label the objects with the names and where the fronts are, all right? And so what we did in scoring sketch maps, and we did this early on in our research, is we scored the sketch maps using the same queries we gave for the direction circles, all right? And in that way, what we did was, recently, is we actually looked and correlated. All right, we had 28 different experimental groups from multiple experiments published. All right, and 24 subjects in every single group. That's our standard size. All right, and what we did was we found a correlation of close to, I think it was 0.89. It's in the slide, on the slide. All right, so you can verify any of these things. Anyway, and it was a very strong correlation, well, with a slope of very close to 1. All right, and when we looked in terms of, there's a way of correcting for slopes because of regression to the mean, because the slopes, all right, basically get lesser than they should be, all right, because of that. All right, somehow, and when you do that, we were basically with a reasonable estimates for the error on the x-axis, our slopes were about 1, which was nice because it's basically showing you that, all right, they got the same units, all right, and it's stepwise, all right, which is what you want in your measures, all right, you know, if you think they're measuring the same thing, all right, and we did, all right, and they both tracked each other in our experience, and they were measuring how much they learned in different situations, and they were agreeing, all right, and so that's why they could correlate like that, all right. But what the big difference was, all right, that the slopes weren't the same, all right. Now here's where it comes in interesting, because what we did is we followed that up, all right, with a model, all right, which was, why are the slopes not the same? We worried about that. All right, and we did follow-up experiments, all right, to look at what's going on. And what we thought was, and correctly, that when people draw sketch maps, they start putting some stuff on a sketch maps, and then they put other stuff on, and the first stuff they put on, the earlier stuff, gives them physical cues for retrieving later spatial information. All right, and so they do better. So what we did was manipulate what they could put on maps and give them things on maps. And we showed that if we took things away totally, that was the most critical thing, all right? And they only could put very skimpy things on maps, all right? The sketch map angular errors, all right, was the same as the pointing directional pointing was. This, you know, the directional circle. And so the points were on top of each other again. All right. Not just the correlation, there was zero slope. All right. Between them. And that, all right. So here's the model. All right. Both measures measure the same amount of memory. All right. Memory representations. All right. You know, the content of memory. But sketch maps, all right, may differ from directional pointing depending upon the retrieval. All right. And there's retrieval differences between them. All right. So here we can correct for that or take it into account. All right. In knowing what we're doing. Do you have that up now? Yeah, there we go. All right. So, and this just shows how we scored the sketch maps with the directional pointing questions. This slide. Go to the next slide, please. I don't have a slide. It went away. What happened?
She took off the old one. She's uploading the new one now, I believe.
Okay.
Can you see it now, or does it not? Okay, wait.
It's coming up.
I don't see it.
Is it there?
Not quite yet, but yes,
There we go.
now it is.
There we go. Okay. This is our direction circle. Next slide. All right. This is an example of a sketch map. This is actually one that we got. It's a better subject, but it's there. And the hallway goes around, and there's 4 rooms in an L shape. Next one. Here is the one you saw before. We're showing you how we score the sketch maps, and they're equivalent to the direction circle. Next one. Here is the correlation. The correlation is 0.89. R squared is 0.79, about 0.8. All right, and here is the argument I went through. Next slide. All right, and this is the conclusion we came to. One measures memory representations. The next one measures the other one, okay? But that's old stuff. That was my quick introduction, which wasn't so quick. All right. Now, what we're now looking at is, the new stuff I want to talk about. Next slide. All right. To use a direction circle, subjects have to be given an angular judgment to make. Next slide. All right. There's 2 different types of judgments that have been used. One is the judgment of relative direction, or the acronym is Jrd. Next slide. This is an example of a Jrd. All right. Imagine you're standing at the Pepsi machine. Now, they've seen these environments, and these objects have been in that environment. Pepsi machine was there. Imagine that you're facing the stove. It was there also. All right. Point to the desk. So it's 3 points, all right, and 3 points to find an angle. All right, next slide. All right, the terminology of Jrd is the base object, is the standing at object, the Pepsi machine. The facing object is the facing the stove, and the target object is the point to the desk. Now, next slide will show you how we use the direction circle. Direction circle for this is used. Standing at means you're the head in the middle of that circle with the nose pointing up to the 0 location. All right. The facing object is at the top of the circle, separate from where you're standing. All right. In some place in the environment. But now you're thinking at wherever it's facing, you face that, imagine facing that, and that's where the top of the circle is. And you point to where the target object is with respect to the facing object. All right. And that's the angle between, all right, the facing object and the thing. And you went to the next slide. That's fine. All right. Because this shows you this relationship. Those are the 3 points. The base object is there. Below it is the facing object. All right. Off to the right is the target object. And that angular arc between those 2 legs of the 3 points form the Jrd angle. All right. Next slide. All right, the other direction circle judgment is an object-based judgment, an OBJ. All right, next slide. They're both done from memory. All right, Imagine, all right, here what the judgment is like. Imagine you are squarely facing the front of the Pepsi machine and an arm's length away. You're right there. You can put the coin in the slot, or you can select whether you want caffeine or not, or diet, all right? And you can reach that, all right? Point to the desk, all right? And so, next slide. Again, the base object is squarely facing an arm's length away. That's the base object. You're right by the Pepsi machine. The target object is point to the desk. There's no facing object. Next slide. All right. Here, using the direction circle. The base, all right, now facing the front of the machine, the head and is you at an arm's length away from the front of the base object at the top of the circle. So you're right there at the top, all right, close to it, all right, you can reach it. And now from there, point, all right, to where the angle is, all right, on the, at the, of the target object. That's the angle between the Pepsi machine and the desk. Next slide. And here you see how we define that. Since you're right there and that front has a surface which is flat, all right, you can get a perpendicular to that surface, all right, and form an angular with a perpendicular to it, all right, to the target, all right, which is below it. And here you see in red, all right, that angle, and that's the OBJ angle, all right, from that. This assumes that, you know, that spatial memory has solid objects in it, and that people pay attention to where the fronts of those objects are or other aspects of them. All right, something distinctive about it. They're not just points in space. It's not a coordinate system per se. All right, next slide. All right, so use of direction circles. All right, most of the research that's been done, especially the recent research, which is really focused on XY coordinate, all right, theories, all right, has been used Jrds, and most of them line up their objects in rows and columns. All right, when they do the research. All right, OBJs has been primarily used by my lab. All right, and a few other articles have used them. They haven't named it the way we do. All right, but OBJs are natural and easy to use. I bolded that, and we'll see that in the next slide. Next slide. I'm going to read this slide. I don't recommend cluttered slides like this to people, but I wanted you to see. This is quote, this whole slide below the title above that is a quote from an article by Hintzman et al. In 1981, I believe it was Cognitive Science, page 151. All right, and they wrote, and this is their whole quote. All right, and Hintzman was, this is the article that Hintzman and them did on spatial memory. All right, in arguing for an analog representation of the environment, Atneve cites the following casual experiment, and the following is a quote he took from Atneve. All right, and notice this was a big argument back in those days between what's being represented. Is it analog or is it propositional? A layout is an analog description. All right, for that. I say to a friend, this is Atneve now speaking. I say to a friend, imagine yourself standing in front of the library about to enter. Now, from that position, point at the law school. Stop. That's an object-based judgment. There's going into the library. You've walked up the steps. You're about to reach the door. All right, you're right in front of it. You can see it, etc. And now you're asked, imagining you're there. You're not there. All right. Imagine you're there. Now imagine. All right. Now point to where the law school would be, and you could do that judgment. It's natural. Read on. All right. Now, from that position, point at the law school. Most people will point without hesitation in the general direction that would be correct if they were in the position indicated. The law school was almost certainly not present in consciousness when the observer assumed the imaginary position, but its location relative to his body seems immediately available on demand. This is Atneve, 1972, page 305. So you can look them all up if you doubt me. All right, 40 and 50 years ago, They saw that OBJs was a natural way of doing it. People haven't been using them very much. All right, I do. All right, I did it naturally. I came into spatial research back, all right, so 20-some years ago, and we developed, all right, this measure, thinking it without looking deeply into the literature, quite frankly, because we were interested in some other stuff, all right, and it was the natural way to measure for me and for my colleague, all right, Gary Reed, who I started this research with, all right. Next slide. All right. How are JRDs and OBJs related? That's our question. Now I want to look at this question, and I want to look at it from, all right, a measurement point of view. All right. And so, all right, JRDs focus on the surface of space. Objects are point in space, the base object is an object, and so on. All right. And OBJs, however, focus on solid objects, all right, and they're and they have a front, and there's rotational judgment information there, and there's an article that did something similar to us, but not really the same, that made the argument that these two kinds of things are different judgments. They're unique. Next slide. All right. So, about a year ago, I had this crazy idea, and I came up with, we now call the component error assumption, all right? And that is on this slide, all right? And it is one, first of all, and this is not terribly, this isn't unusual, the homogeneity assumption. They both are measuring the same kind of cognitive processes, all right? However, all right, the second assumption, second part of that is much more critical. Each object has angular judgment error associated with it. All right. All right. With coordinate systems, everything is more tightly linked. All right, with objects. All right. And so you change an object, you should change your relationships to other objects. It's really, and so on. All right. All right. And so now if we look at OBJs and JRDs, the base objects, all right, should have no error or very little or things, because the subject's right there. All right, whether it's a standing object or whether it's the base object for an OBJ. However, for an OBJ judgment, it has one distant object, the target object. All right, therefore there's only one source of angular error. For JRDs, there's two distant objects, the facing object and the target object. There should be two sources of angular error. And so we can predict now angular error from correctly chosen pairs of OBJ angular errors. Next slide. Next slide. All right. So two sources of angular error, all right, can be predicted from estimating things. All right. And, oh, wait, you're going, you backed up someplace. Either that or my file is very distorted. What's going on? I need the next diagram. You won't understand this at all without seeing the next diagram. Yeah, I wish I had I couldn't find how to put slide numbers on with this version of PowerPoint. There we go. All right. Facing angles are things. So take a look at this upper left-hand corner, and we're going to look at those lines and arrows. If you look at the two black arrows, all right, and look at that, that's the OBJ judgment. The base is the refrigerator, all right? The dryer, with the arrow going down to the dryer, all right, is the facing object, and the other arrow going down to the stove, okay, is the target object. And if you look between those two legs of the angle, all right, you start seeing an angular arc in black. That's the JRD angle to be estimated. Now this is all right, what is really in the environment. But what our notion is for a model is this is going on in the head, not as diagrams like that, but by functionally of what they view in terms of the object themselves and how those is the relationships are. And we can capture it with this diagram. All right, but what actually is going on in the head are only maps into that. All right, it's not what they're actually doing. All right, now let's look at the OBJs. Now there's a pair of OBJs that we have, but if you look then for the refrigerator, the black, thick black line at the front is the front of it, and then that horizontal red line is that perpendicular to the front. So we look at angles from that. So first we look at the angle for the first query, which is the query, all right, going to the dryer, the facing object. And that's the big angle, all right, red angular arc, all right? And then as it jumped here. And then we have the second OBJ that is going to predict this JRD that goes from that same base angle like that to the target object. And that's the little angular arc that goes to the other leg. All right, the one's going to the stove. Now look at those two red angular arcs and look at that black angular arc, and what do you see right away? All right, that the difference between those two red legs, all right, is the same as the black angle, the difference between the two angles. So we can predict the JRD from those differences, all right, from the OBJ differences. All right, next slide. All right, so, all right. Ooh, have you jumped ahead? Is this really the next slide? Okay.
That's the one that's
No.
next.
What?
Yes. That's next.
Okay, we're missing slides. Here. Is this before or after? Okay, after, okay.
This is
All right,
where we
back
were.
up to that first slide, the one right after this one. Okay, so the procedure is, all right, so we did an experiment testing it. All right, and I thought I gave and I know I had a slide in there giving the design. All right, I don't know what happened to it. All right, yeah, go to that first procedure thing. Is this the first one right after that? Yeah, all right, and so this is the way we run experiments. All right, we basically have people hear about the scenario, all right, and the task they have to perform. Because we don't tell people, I want you to go in this environment and study it and find out where things are. We tell people, hey, all right, you have this job here. You're in this case, they were an inventory clerk. All right, you're an inventory clerk. You're working in a warehouse. All right, things come in on trucks. You have to check them off on the inventory. All right, to make sure that we've got them and so on. And that's what you're going to be doing. All right, in this scenario. And so, and you have to follow the inventory list. All right, because that's the company policy, and that's what they're told. All right, and now after they get told that, they start seeing this video. All right, it's a video of a first-person point of view. All right, moving through this virtual, all right, building. All right, now we created this in our virtual environment program, the SketchUp. All right, and all subjects, all right, see the same video because we wanted to make sure that their spatial experience was the same. We did learning. That's what we do in learning studies. We give them the same material to learn. All right, and when when we let them control navigation, which we've done in early experiments, all right, every subject has different navigation. All right, and so, they go and they see all 16 landmarks. They stand in front of each one at an arm's length away. All right, and they're told characteristics of the object. All right, and then they're told the next object to visit until they go through all 16. And they come into the doorway, they go out the doorway, go out down the hallway, go into the next room. Okay, the video takes 12 minutes. They get a learning experience of 12 minutes in a spatial environment. And then they get memory tests. They get a free recall test of the landmark names. I'm not going to talk about that today. All right. Then they do the direction circle. All right. Well, each subject only gets one of the judgments. either the JRD, the dual OBJ, and then we added the OBJ. That would have been totaled in a slide you didn't see. All right, because we wanted a methodology you see it was there, and we developed this new dual OBJ, which apparently we've never seen. All right, interesting. All right, and then they did a sketch map. Next slide. You don't have a dual OBJ slide, do you? All right, well, I'll talk about it. All right, okay, all right. The dual OBJ we developed, all right? Most direction circles, they just mark one location on the direction circle. Well, we were worried about trying to confounding things. If we do two OBJs, well, then they'd be on separate trials. And in fact, if we did it under normal conditions, they'd be randomly mixed up. But even if we put them side by side, they get one and then they get another one, and they're not integrating the information closer in time. All right, and so there's working memory or short-term memory things that could affect the error that's going into this. All right, and be a separate source of error, and we wanted to minimize that. So we developed what we call the dual OBJ, and what they get is on one direction circle, they get the first OBJ, the base query, and then the target, and then you get right underneath that the second one, and that's for the facing object, and then they get this is the second one which goes from the base to the JRD's target, all right, and they do them in that order, all right, and they put them on the order and they label them for which one is which, all right, and the example showed you that, all right, so, all right. And so and we did that to minimize that, and so the design is all set up to mainly compare JRDs versus dual OBJs. The OBJ was a methodological thing, which was not the main comparison. So the virtual environment was the one you saw before, 4 rooms with 4 landmarks objects per room. All right, each room, one room was a vending machine room with the Gatorade, water machine, lemonade machine, coffee machine, appliance room with refrigerator, stove, dryer, washer, you can read it. Furniture room, dresser. The desk was actually an old antique-like secretary desk where the top this thing folds down into a level thing, all right, and an armchair and a sofa, and then the games were a dancing game. Smash Brothers was a Mario Brothers type game, all right, and hunting game was a rifle game, and then a racing game. Next slide. Okay, this was part of, navigational cast. The objects were put into rooms randomly placed. All right, and so we did a random place. We put coordinate locations in there. All right, and we randomly placed them. The order of visiting objects within a room that was randomly placed within each room. Each room had a function. All right. We basically randomized the order of visiting objects. All right, and going between navigation paths, they were sweeping, and we balanced whether they were sweeping to the left or sweeping to the right. And then we did basically the object orientation rotations. They were balanced, all right, in terms of where the fronts were located, all right, and only 2 could be in the same facing direction in a room. Next slide. This is a view right in the inside of the first room, the vending machine room, and you see the coffee machine and the water machine. Next slide. Here's the design. All right, the main analysis was this 2x2 mixed factorial. The between subject factor was that judgment. They did separate judgments with separate groups. All right, JRD or dual OBJ, and then the repeated measure factor was this facing object thing, and the slide we couldn't see, all right, actually had it on, and I back it up, but I can just tell you about it. What we did was, all right, we matched what happens is if you put objects in, if you ask queries and the objects are in different rooms, all right, then what happens is, all right, your angular error goes way up. They don't learn as much. All right, it's a harder thing for them to learn when about angular relationships with objects in different rooms, especially when you go through hallways. All right, from room to room. All right, which is what the experiment was. All right, and here you can see it. What we did is we matched the angle between the within room one with dryer and the Gatorade one. All right, which was the between room one, and that's for all of the queries we did that. And so that was because JRD research, they're very sensitive about angle things. All right. And so we basically matched that. All right. But all right, we still expected to find this room location effect. And what we did that for was because this put a big performance difference on, which again is good to do when you're trying to see if measures are working. Secondly, all right, the types of information that people use and the processes are probably different between room and within room kinds of things. They have to do potentially different inferences or something for between room. Okay, so all right, so 32 trials, all right, 16 in each, 24 subjects, all right, per group, all right, and these are intro psychs people, and it was an hour-and-a-half session. That's the maximum time. Some people went there, but many people finished a little bit earlier before that because they can't control of that. All right. So the dependent variable is important because what did we measure? For the JRD group, we measured their JRD response and look at the error in that. For the dual OBJ group, we didn't measure OBJ angular error. What we did is we measured the estimated JRD absolute angular error, all right, using the computation that I showed you, all right, from that. And in all cases, we're looking at absolute angular error. That's the absolute value of the difference between, all right, the measure you got and the correct answer, all right, between it. And that's the shortest distance around the circle. And it's easy to calculate. You don't have to play games. Next slide. Here's our lab, 6 things in a booth. Every subject, when they're multiple subjects, has different experimental condition. Next slide. Here's the data. Look in the upper left-hand corner. All right, I was going to use my cursor to walk you through this. All right, and because that's the main of things. The solid line is the dual OBJ. The dashed line is the JRD. On the x-axis is the facing object room location. To the left is the within room. To the right is between room. Those are what's in the queries. Remember, half for each. All right. On the y-axis is the JRD or the estimated JRD. All right, depending upon the group. All right, and notice that they're very similar. All right, next slide. I don't usually present these kinds of detailed statistics in talks, but it's critical for this. All right, because this is the, it's a 2x2. All right, the first thing is the judgment effect. All right, and you start seeing that the F ratio is less than 1. There's a bunch of error. The mean square error is fairly substantial here. All right, there's not much percentage variance accounted for. P-value is 0.44. The second one down is this other main effect, which is the facing object room location. Notice what a big effect is there. That's an F ratio of 30. All right. And all right, it's counting for 40% of the variance. All right, with a partial eta squared. All right. And the p-value is way below. All right. 0.001. All right. It's a big effect. All right. But the third one is the most important one because it's got a low error there. Mean square error is only about 1/4 of that between subject error. It's a repeated measure type design, mixed design here. All right. The F ratio is less than 1. All right. But notice what it's telling us. Given that there is no main effect, it's telling us the points are on top of each other within measurement error. All right. And for that. And here we start seeing, all right, that it counts for 1% of the error. All right. And the p-value is 0.45. No difference. Okay. What time do I have? Wait, I got my clock here. Okay. Okay. I'm going to go through the next experiment real fast. So To the right was OBJs. We found the same results. We did the sketch map things. We found the same results. All right, and so there was no other kinds of things, and we were surprised that the OBJs by themselves worked out. But we're still using dual OBJs because they're much more conservative in terms of assumptions made. Next slide. All right, so all right, the second experiment we did was no hallway navigation, and we did that, all right, for two reasons, all right, and the main one is that, all right, when you go directly from room to room, all right, you basically, all right, you learn more. You have less angular between room angular error. The between room doesn't change. All right, the between room changes. All right, and what happens is that you know, they may have more different kind of information because of the nature of this between room information. All right, and so we thought, okay, let's see if what's happening here. Now we didn't like it because it's going to have a smaller, big effect for the facing room thing, but we now think we can generalize at least a little. We have another experiment going on that we're just about we're working on that's going to generalize it to some very different kind of conditions if it works. And we're going to try to do it. Next slide. All right. Oh, okay. I'm just showing you where the doorways were. These little things here, when they're in hallways, that's where the doorways were. All right. When they went room to room, they started inside the room at this doorway location, went through the all the environments exactly the same way, same pathways. When they hit the last object, they went to this doorway, all right, and went through it because the hash marks or the pound sign, as I call them, all right, they'd go in and they'd walk around the walls until they got to the doorway location, all right, and then they'd go through the room exactly the same way again. And they did that for all the rooms. All right, next slide. Okay, and so basically, this is just telling me what I did before, that with no hallways, they do better. And in previous experiments, we couldn't do it in this experiment because of the limitations where we wanted to equalize those angles and so on. All right, but they could see some of the objects from one room to another, but very little. All right, and in previous experiments, they couldn't see any objects from the next room until they got into that room. We arranged the rooms in that way and the objects. All right, and so and you still got a big reduction, all right, in the amount of error in what's going on. So next slide. All right, same results. That the upper left-hand one, that may look like a bigger difference, but it's not there. This is the between subject effect, those two lines. All right, and so between it. Next slide. And here you see the judgment effect is an F ratio 1.3. All right, it accounts for 3% of the variance, and the p-value is 0.26. That's not real, that difference. All right. Again, a substantial amount. The F ratio for the facing object, the middle one down below, all right, is 8.3. Okay. Mean square again is about, is much smaller. All right, about the same as it was for the last experiment, the mean for the repeated measures mean square. It accounts for 15% of the variance, and it's a point value of 0.006. These are big effects. All right. The third one is again the most important one, and here we start seeing, all right, the F ratio is less than 1. The mean square is small for this one also, all right, and it counts for 0.1% of the variance, okay, and the p-value is 0.8. That's nothing going on there. All right, next slide. And the same thing happens for the other measures. They all agree with those analyses. Next slide. All right. So we did a combined analysis, all right, of experiment 1 and 2, and we added experiment as a factor. So it's a 2 by 2 by 2, all right, design. The top two things just show you the big effects going on for the manipulations. So you see the facing object thing, all by the main effect for it has an F ratio of 50. That's a big effect. All right. The second one tells you that the two experiments did vary in terms of what they did, because that interaction between just the facing object, all right, and the experiment, all right, is significant, all right, 0.002, all right, F ratio of 10. The bottom part says no main effect for judgment or interactions with it. And I've highlighted the most important one, but none of them were significant, and most of them, or I think all, were less than 1. All right, is the judgment by phasing object location. That's the one that's sensitive to the points, given that the judgment wasn't significant, and it wasn't. All right, it's the one right above it. All right, that was 1.06. Sorry, it wasn't less than 1. All right, and here we start seeing that thing, all right, with small error, all right, again, a little bit of error, 166, all right, mean square, all right, with twice the amount of subjects, twice the amount of degrees of freedom, is the F ratio of less than 1.39. All right, and it basically only accounts for 0.4% of error, and the p-value is 0.5. All right, and so there's no differences there. All right, and in that. So, all right. So next slide. This one I'm going to talk to you very quickly because I think I'm running out of time. All right. What we did was we now analyzed everything, the 2 OBJ measures, separately with OBJ dependent variables. And we found out where was the error in this? The Jrds is this difference score error. Where was the error? Now we only manipulated the facing error. And what we found was that's the only place that error showed up was in the facing object. All right, that's on the left-hand side there, the difference score, that things. All right, and when we did the analysis, there was no error, no difference in between versus within for the things. Well, if they think the facing object is in the wrong location, all right, in the wrong facing angle, shouldn't that affect where they put the target object? Shouldn't there be error there? Well, there wasn't. All right, that's what tightly linked systems do. All right, and so that's why we think, all right, there isn't. So next slide. So conclusion is we have evidence, we're following it up. We have 2 more, we have a study we're doing, and we have another one we're planning on doing. We'll probably which are going to start testing other possibilities. Except in those hypotheses, we found with between subject vectors and with these sample sizes and these kinds of manipulations, we have found a bunch of effects before. All right, we find none here. All right, and so we don't think it's just not there. But the more times you get it, the more confidence we have. It really is the same. And in second big bullet point, all right, when you test models, that's what you do. You see if the data fit the model, and you're often estimating pre-parameters. This model has no free parameters. And what is this? This is like calculating, all right, a force by looking at what happens to work and knowing the relationship between force and work, all right? Because what we're doing is we have a mental model relating these 2 measures. We're not just saying they're correlated or whatever. We have a mental model saying, here's what we do to get the same point things. And this model doesn't have free parameters, all right, in it. All right, and so we think it's different, and the OBJ analysis makes a suggestion that maybe this assumption that things aren't as tightly linked in coordinate systems as most people think. Next slide. So we think that, all right, spatial memory, all right, doesn't just have XY coordinates. It has XY coordinates, the second bullet, plus object rotation, which means that we need models for that. And our theory has that notion in it, that you basically have that, all right? And like the next slide, I'm not going to go over the rest of it, all right, is how should this be used, all right? Will this hold universally? I doubt it. Very few things do. But what's important is, all right, instead of just trying to disprove it or prove it, is that we should use it as finding out where it holds and where it doesn't. All right, because this is the kind of thing, all right, that we've done with recognition versus recall, with declarative versus non-declarative memory. And we have identified things by looking at, all right, the differences between them, not just trying to say, oh, look at, that's wrong. All right. And finally, all right, we now have relationships between, we think, Jrds and Objs, all right, and between Objs and sketch maps. And I now have data on actually map recognition using signal detection theory with area underneath the curve to show similar kinds of things. And we think with these kinds of measures, we can have a better idea of what human spatial memory is like. And thank you. I'm sorry for the kind of mix-up.
Thank you, Herb. Thank you all. Unfortunately, we don't have time for questions. If
you want to come to my lab, I'm in 423 Fawcett, or send me an email or call me. All right, and I'd be happy to show you some more stuff. Okay, thank you.
Great, thank
Bye.
you. Bye-bye.
Bye-bye. Thanks, Jan.
Thank you.